Ever wondered how methods in object-oriented programming work? Well, you're in the right place. In the realm of programming, methods are the heart and soul of object-oriented programming, or OOP for short. Think of them as functions that are linked with a particular class, defining the behaviors or actions that objects of that class can perform. They work on the data attributes of the class and encapsulate the functionality that's related to the class. Some of the key concepts we'll be exploring include method declaration, the self-parameter, the constructor method, and instance methods. We'll also delve into class methods, static methods, getter and setter methods, the destructor method, and the fascinating world of method overloading and overriding. Buckle up and get ready to dive into the intriguing mechanics of methods in object-oriented programming. Stay tuned as we delve deeper into the mechanics of methods. First up, let's talk about method declaration and the self-parameter. When we speak of method declaration, we're essentially talking about defining the method's blueprint. This blueprint, in Python for example, starts with the def keyword, followed by the method name and then parentheses enclosing the method's parameters. It's a little like shouting out your order at a food truck. We're telling Python exactly what we want to cook up. Now, inside these parentheses is where the self-parameter comes into play. Picture it as your personal assistant, always ready and waiting to help. In Python, the self parameter is a reference to the current instance of the class. It's the first parameter that every method in a class must have. The self parameter gives us access to the instance's attributes and other methods. It's like a backstage pass, allowing us to interact with all the elements of the class. So when you see self in your code, remember it's your VIP ticket to all the attributes and methods in the current instance of the class. You might ask why it is called self. Well, self is not a reserved keyword in Python, it's a convention. You could name it anything you like, but sticking to self helps other programmers understand your code better. Let's imagine a class named robot. If we have a method within this class to introduce the robot, the self parameter allows us to access the robot's name, its model, and any other attribute that we've defined. So the self parameter helps the method to understand which specific robot we're talking about. In essence, the self parameter is a way to carry data from one method to another within the class. It's like a courier, delivering information about the specific instance of the class to the method that needs it. With these basics, you're ready to start creating methods of your own. Remember, declaring a method is like giving instructions to a food truck, and the self parameter is your backstage pass to all the attributes and methods within the class. Happy coding! Now, let's dive into constructor methods and instance methods. Constructor methods, known in Python as, are special methods used to initialize the attributes of an object when it's created. Think of them as the blueprint that sets up your object with all the attributes it needs right from the get-go. On the other hand, instance methods operate on an instance of the class. They have full access to the instance's attributes and other methods. An example of an instance method might be a speak method on a dog class. This method could use the dog's name and breed attributes to print out a statement like Fido the golden retriever barks loudly. In essence, constructor methods get your objects set up and ready to go, while instance methods define the unique behaviors and actions your objects can perform. These methods bring your objects to life. Scene script. Next, we'll explore class methods and static methods. Diving right in, let's start with class methods. Class methods are a unique breed of methods that are bound to the class, not the instance of the class. They are defined using the @class method decorator. When you call a class method, it's the class, not the instance. That's the first argument. These methods can't modify a class instance state. They are generally used for factory methods, which can be used to create an instance of a class in different ways. On the other hand, we have static methods. Static methods are not bound to the instance or class. They don't have access to any of the data specific to an instance or class. They are primarily a way to write utility functions which belong to a class. In Python, they are defined using the @static method decorator. These methods are not able to access or modify instance-specific or class-specific data, which might seem limiting, but it's actually very powerful. It ensures that the method does not modify the state of the instance or the class, which can be crucial for writing safe code. Now you might be wondering, what's the difference between these two? Well, the key difference lies in their access to the class and instance data. Class methods can access and modify the class state, while static methods can't access or modify the class or instance state. They operate independently. However, both these types of methods serve their own purposes. Class methods allow you to add functionality that is related to the class in general, rather than tied to a specific instance of the class. Static methods, on the other hand, allow you to add functionality that doesn't depend on the class or instance state, which can be really useful for writing utility functions. These methods give you more flexibility in how you use your class. Moving on, let's discuss getter and setter methods. These two types of methods play a critical role in controlling access to class attributes in object-oriented programming. Getter methods, as the name suggests, are used to retrieve the values of class attributes. Think of them as the gatekeepers, ensuring you have the right access to view the information held within an object's attribute. On the other hand, setter methods are in charge of setting or modifying the values of these attributes. They act as safeguards, regulating the alteration of data encapsulated within an object. Both getter and setter methods help uphold the principle of data encapsulation, a cornerstone of OOP. They provide a controlled way to access and modify the data attributes of a class, preventing unauthorized access and ensuring the integrity of your data. In essence, getter and setter methods serve as a protective shield, maintaining the security and integrity of your data within the class. Lastly, we'll cover the destructor method, method overloading, and method overriding. Let's begin with the destructor method. This is a special type of method, known as in Python, which is invoked when an object is about to be destroyed. This method is typically used for cleanup activities such as releasing resources or closing database connections. However, it's important to remember that the timing of destruction isn't predictable in Python due to its garbage collection system. Therefore, relying on the destructor for crucial cleanup tasks is generally not recommended. Next up is method overloading. This is when multiple methods have the same name but different parameters. It allows you to use the same method name for different operations, depending on the arguments you pass. For instance, a volume method might calculate the volume of different shapes based on the number and type of parameters provided. However, not all programming languages support method overloading directly. In languages like Python, you can achieve similar functionality using default parameters or variable length argument lists. Lastly, let's look at method overriding. This is when a subclass provides a specific implementation for a method that is already provided by its superclass. It allows subclasses to change the behavior of a method to suit their needs. For example, a print method in a superclass might simply print a message, while in the subclass, it could be overridden to print a formatted message. So there you have it. Destructor methods help manage object lifecycle. Method overloading provides flexibility in method usage. And method overriding allows subclasses to customize the behavior of inherited methods. These concepts allow you to manage and customize your methods effectively. Remember, a solid grasp of these concepts is key to leveraging the full power of object-oriented programming, so don't hesitate to revisit these topics until you're comfortable with them. Keep practicing, keep coding, and see you in the next video. Now that we've covered the basics, let's recap what we've learned. We started with method declaration, where we saw that methods are functions associated with a class. We then touched on the self parameter, the key to accessing attributes and other methods within a class. We explored the constructor method, which initializes attributes when an object is created, and instance methods that operate on an instance of the class. Class methods, on the other hand, are bound to the class, not the instance. We also delved into static methods, which are not bound to either the instance or class, and getter and setter methods, which provide controlled access to class attributes. We wrapped up with the destructor method, which releases resources when an object is about to be destroyed, and method overloading and overriding, which provide flexibility in method usage. Remember, practice makes perfect. So start implementing these concepts in your own codes and see the magic happen.